Unit 9, Lesson 2 notes for factoring trinomials. Alright, so the first two screens here are really just like a review, and then basically we've got screens 3, 4, 5, 6, 7, 8, 6 examples to kind of go through what we're doing with factoring. And again, understand too, we're going to do lesson 3 will just be a lot more of this same skills. So it's not like, oh my gosh, a totally new thing in one day. Like, we are doing this. It's a process. It takes time. So please understand and recognize, like, we're not doing this just in one class period. You want to constantly improve, constantly get better, but yet at the same point, you want to recognize that, like, you're not supposed to get there in a day, right? It's a process. Okay, so with that being said, these first two, like I said, are review. So this is really what we were hoping to learn from lesson 1 in Unit 9. So taking out a GCF, and you'll notice here with what we do with factoring that this is actually going to be a big part of what we do too. So we do need to get good at this skill. Okay, so we've got 14 and 20. We need to take a GCF. So 2 is the number that divides into both of those, and then they both have at least x to the first. Remember, you want to take out the variable exponent, the smallest variable exponent you see, which is x to the first. So remember how we write this from the first lesson. We put that on the outside. Now we're going to divide. So 7 divided by 2, or sorry, 14 divided by 2 is 7. Remember, when we're asked to divide exponents, we actually subtract them. So 2 over 1 is just x to the first. 20 divided by 2 is 10. And then x over x cancels, so we're just left with this. So we look to match up that answer, which would be this right here. All right, so let's look at one more like that. So here we go. We got 2x squared plus 8x. So we're going to take out a GCF here. So my GCF here should be 2x. So we take out that 2x, boom, and now we write what's left over. 2 divided by 2 is 1, but you only need to write the 1 if everything else cancels. And that's not going to be true here because x squared over x leaves me with x. 8 divided by 2, 4. Now the x's here are going to cancel because they're both just x to the first. So there's my answer. So then there we go. Okay, so that's really the review from the first lesson in the unit, okay, on screens 1 and 2. So now let's get into what the heck are we actually doing in this lesson. So we're learning to factor these trinomials. So it's really just a process, and it's just a process you have to learn and you have to get better at over time just through practicing, okay? All right, so I'll kind of work through each of these 6 examples here. You can check them out, and then remember your asynchronous work is then to do screens 9 through 12, so make sure that you take the time to do those so that you're getting that practice leading into next week. Okay, so first thing is I just copy the problem. Then I set up the x over here, our factoring tree. So now I need 2 numbers, and I've got to figure out what these numbers are. So the first thing I need to figure out is what I need these 2 numbers to add to. So they're always going to add to whatever the coefficient in front of x is. So this is a -2. I put a -2 here. Now I need to figure out what they need to multiply to. So what we're going to do there is we're going to multiply the last number, the -63, times whatever the coefficient in front of x is. But remember, if there's no number here, it's just implied to be a 1. So it's really like 1 times -63, which is, oh yeah, -63. And now you just have to take some time to go back to your middle school math skills to think, what are 2 numbers that when I multiply I get -63, and when I add I get -2? And if you need to, you use the calculator to check, and you start dividing 63 by 1, by 2, by 3, by 4. And you keep working your way up until you get 2 numbers, no decimals ever with factoring, that are 2 away from each other. So those numbers would be 9 and 7, right? 9 times 7 is 63, and they're 2 away from each other. So now you just have to figure out which one's positive and which one is negative. In this case, the 9 is going to be negative, and the 7 should be positive because they have to add to a negative number, so the bigger number has to be negative. Okay, so the next step is we're going to bring down our first term. This process is called factoring by grouping. Bring down that first term, it doesn't change, nothing happens. Leave some space, close parenthesis, open parenthesis, leave some space. And then you're going to bring down that last term, the -63. Okay, so now from here, what we're going to do is I'm going to split the middle, this -2x, into these 2 terms, the -9 and the +7. They can actually go in either location. I'm going to put the -9x here and the 7x here, but in class I'll show you why technically it doesn't even really matter. You can get the right answer either way. And now we have 2 of these binomial sets, which is kind of like, isn't that what we did here? So we're going to take a GCF out of this first set, which is x. So we take that to the outside. Now we're going to go divide. X squared over x is x. Divide. The x's cancel. We just bring down the negative 9. Now we do it here. So 7 divides into these. Put the sign with it so you know what sign you're working with. So that's a plus 7. Divide here. You're just left with x. Divide here. You're left with negative 9. Okay, now there's a built-in check for each of these questions. If these factors match, see how they're both x minus 9? So you write x minus 9 one time, and then the two GCFs, the x and the plus 7, form your other factor. Boom. X minus 9 and x plus 7, and that would be the factoring for this problem. Now, I'll show this check one time, and then you can do it any time you'd like, but just for time's sake, I'm not going to show it over and over. We really can check this by reviewing from the last unit. So we put the x minus 9 here, we put the x plus 7 here, and now we're going to just go ahead and fill out our box. So x times x is x squared, x times negative 9 is negative 9x, x times 7 is positive 7x, 7 times negative 9 is negative 63, and now we are going to combine these like terms. So negative 9x and 7x is going to give me negative 2x. And really this is just like review from Unit 8. Get the x squared, get the negative 63, and you'll notice, oh, this is what we started with, which is exactly what we want. So now we've gotten this, right? So basically we're doing what we did in Unit 8, just in reverse, right? In Unit 8 we started with this and said, hey, what's the product? And you multiplied it together to get here. So now we're just starting with this and saying, what are the two factors? Okay, so let's just show some other examples here. Okay, so first I copy the problem. So 5x squared, plus 11x plus 2. Right away, I set up my multiplication setup. I set up my addition. So it has to add to this middle number, so whatever this number is, the coefficient in front of x. If there was nothing there, it'd be a 0, like if there was no x term at all. If this just said plus x with no number, it'd be like a positive 1. If it just said minus x with no number, it'd be like a negative 1. In this case, I see an 11, so I'm going to write plus 11. All right, what does it have to multiply to? Well, it's got to be the first term times the last term, so 5 times 2, positive 10. Okay, then you got to come up with the numbers. What are two numbers? So when you multiply, you get positive 10. When you add, you get positive 11. Well, pretty quick, I hope, you would come up with positive 1 and positive 10. When we get to harder numbers here in a couple, I'll show you how to use the calculator to help you, but you could use it at any point in time. Okay, just like I did on the last example, I bring down the first term. So the 5x squared comes straight down. I bring down the plus 2. It comes straight down. I split the middle, the 11x, I split that up into what we just found, right? So what did we just find? Oh, the 1 and the 10. So you can pair them up wherever you want. I'm going to put the 10x here and the 1x here, although really you could do it either way. Okay, I'm going to take a GCF out of here, which is going to be 5x. Sorry, I was getting ahead of myself there. Now I divide. 5 divided by 5 is 1. I only need to put the 1 if everything else cancels. X squared over x is just x. 10 divided by 5 is 2. And x over x cancels. Okay, back here, I can't take anything out, so I'm just going to do a 1. Remember, you can always have a 1 as a GCF. Divide by 1, nothing happens. So notice our check here. Are these the same? Yes. So since those are the same, you're going to write that down one time. And then your two GCFs form the other factor. So we get x plus 2 and 5x plus 1. Alright, so let's just continue to kind of show these, okay, so we can see what we need to do here. Alright, so again, I start with just copying the problem, and then again, you'll see, like, this is just a process. As you get better and better and better at the process, then you get better and better at the work, and then it goes a little quicker too. So you set up the multiplication setup for my factoring tree. I needed to add. So I always start with the add. I needed to add to whatever's in front of the x term. Oops, I put a squared there. Hold on. Get rid of that. So that would be a 5. So I'm going to put a plus 5. And I always put the signs with it. I never just write a 5 or a 2. I always write plus 2, plus 5, minus 2, whatever. Okay, then it's got to be 3 times 2. Well, 3 times 2 is positive 6. So I need two numbers that multiply to positive 6 but add to positive 5. Well, I would hope that all of you could pretty quickly come up with positive 2 and positive 3. Okay, so now I bring down the first term, 3x squared. I bring down the last term, positive 2. And now I'm going to split the middle, so the 5x, into what? Oh yeah, these two numbers that we just found. Now I know I said earlier they could go wherever they want, which they can, but you might as well pair them up with its closest like term, right? Why not put the 3 with the 3 and the 2 with the 2? So I'm going to put my 2x here. I'm going to put my 3x here. GCF here, well, what goes into 3 and 3? How about 3? And then they also have an x in common, so 3x. So I take the 3x outside. 3 divided by 3 is 1. Again, we only need to put that if everything else would cancel. X squared over x is x. Whereas here, the x's cancel. 3 over 3 is 1, so we do need to put a 1. Okay, the second term, I think it's pretty obvious. The GCF needs to be a 2. Take a 2 out. Let's divide. The 2's cancel. You're just left with x. 2 divided by 2 is 1. Okay. Again, at this point, we know we are correct. How do we know we're right? The two inside terms match. So you write the x plus 1 one time. And then you write the two GCFs as the other factor. And there we go. So it'd be x plus 1 and 3x plus 2. Now this would still be considered a fairly straightforward one because the numbers are small and they're all positive. Alright, so let's do one more like that where the numbers are pretty small and they're all positive, and then on screen 7 and 8 we'll see kind of the hardest types because they're bigger numbers and they're not just all positive. So you have to be a lot more careful with the signs. And when we do 7 and 8, I'll also show it where I use the calculator to help me in case you're at a place where you need to use the calculator, because we all get to a place where the numbers are too big and too complicated to figure it out. Okay. So in this case, they're not. So this should be 11. So we should be adding to positive 11, multiplying to 24 times. Remember, this is just like a 1. So 1 times 24. All right, so hopefully you can just do this in your head. I think about what multiplies to 24, right? For me, the first thing I think of is 4 times 6. But 4 times 6 isn't 11, it's 10. So I got to keep coming up with more numbers, right? 2 and 12, but that would add to 14. How about 3 and 8? There we go. So positive 3 and positive 8. Okay, so again, same process from here. I bring down the first term, x squared. I bring down the last term, the positive 24. And then from there, I'm going to split the middle into those terms that I just said. So I'm going to split this 11x up. What do I split it into? 3x and 8x, right? So plus 3x plus 8x. Okay, GCF here, well, what do they have in common? They only have x in common. So I take out x. X squared divided by x is x. 3x over x, well, the x's are going to cancel, and I need to keep that 3. Okay, back here, my GCF should be a positive 8, right? So a positive 8. So I do that. 8 over 8, just using x. 24 over 8, 3. Okay, how do I know I'm correct at this point? Well, the two factors match. So I get x plus 3. And then I've got my two GCFs, and that forms the other factor. So x plus 3 and then x plus 8. Done. Okay, so let's go to the ones that involve a little bit trickier stuff. So these aren't different. Nothing's going to change in terms of the process. The part that's harder is the numbers are going to be bigger when we set up our factoring x, and there you got to pay attention to the signs. So that's really the part that's different. So it's still got to just add to this middle number, right? So that's got to be a 4, so it adds the 4. And then what does it have to multiply to? Well, again, 3 times negative 15, which is negative 45. So now I'm going to model this with a calculator for how I would do this. So I go, 45. I need numbers that multiply to negative 45. So I go negative 45 divided by, and I start with 1. So we see what we get here. Hit this button. If you get any number that's not a decimal, you should try it. So 1 and negative 45. But that gives me negative 44. I need 4. So that doesn't work. So I'm going to keep going up. So I do a 2. Again, if I get a decimal, we don't care, so I just keep going. There's no decimals with factoring at all. So 3. So now I have 3 and negative 15. Oh, well, let's try that. So 3 and negative 15. Oh, that's negative 12. We want 4. So let's keep working. 4, that's a decimal, don't care. 5. 5 and negative 9. So let's try that. 5 and negative 9. Well, that gives me negative 4. I need positive 4. So hopefully you could go, wait a minute. How do I make this into positive 4? What if I make the 5 negative and the 9 positive? There we go. So there are my numbers. Negative 5 and positive 9. And if you need to use the calculator for that, do it. You just got to make sure that you know how to do it so that you can work through it. So I bring down the 3x squared. I bring down the negative 15. Again, that part is staying the same each time. Now I'm going to split the middle from the 4x, and I'm going to split it into, oh yeah, these terms. So here we go. I'll put my 9x here. I'll put my negative 5x here. Okay, over here, the only thing they have in common that can be a GCF is x. So I take x out. When I do that, the 3 has to stay. Well, x squared divided by x gives me x. Here, the x's cancel, and we bring down that negative 5. Okay, what about back here? Well, we're going to divide out what? A positive 3. 3 divides into both of those. 9 divided by 3 is 3. Bring the x down with it. Negative 15 divided by 3 is negative 5. I know this works because these factors match. So I'm going to write that down one time. And then the two GCFs form the other factor. So there's my other factor. Boom. Okay. All right, so let's go to the last example here, which is 8. So again, I'm going to copy the problem. So 10x squared plus 31x minus 14. And again, it's going to be a similar process. It's just we have to pay attention to the signs, pay attention to the numbers, right? So it's got to add to positive 31. It's got to multiply. What does it have to multiply to again? Oh yeah, first term 10 times last term, negative 14. Negative 140. Now again, like what could we do right away? We don't even know these numbers. Don't I know, hey, I'm going to have to bring down this first term, negative 10x squared. I'm going to have to leave some space. I'm going to have to open new parentheses. I'm going to bring down this last term, the negative 14, right? Like I'm going to have to do those things anyway. And now the key thing I need to do is figure out what numbers work for this. So when I split the middle, I know what numbers to put down here, right? Okay, so I need two numbers that multiply negative 140, but when I add them, they add to 31. So again, this is probably where you're not coming up with those off the top of your head, so that's okay. We're going to use the calculator. So I go here, and I always do it with a 1. Okay, obviously it's not going to like work, but it just sets it up. 1 and negative 140. That's negative 139. We need them to be 31 away from each other, right? 31 away from each other. So let's keep going. 2, well that does, so hopefully we would all know that those are still not going to be 31 away, but we're getting closer. All right, so 3, again, no decimals ever, so just move on. 4 and negative 35, so let's try that. 4, negative 35, boom. Well, we need positive 31. This is negative 31, so let's switch both these signs. Negative 4, positive 35. There we go. So now we toss our negative 4 up in here and our positive 35 in here. And now I can pair them up wherever I want. I'm going to put the negative 4 here. I'm going to put the positive 35 here. I'm going to take a GCF out of here. What divides into 10 and 35? 5. They have an x in common. So I take 5x outside. I'm going to divide. 10 divided by 5, 2. X squared over x is x. 35 divided by 5, 7. X over x, cancel. Boom. Okay, GCF here. Well, notice they're both negative, so I'm going to take out a negative. And really I'm looking at this first term. If this is negative right here, I'm going to take out a negative. What divides into both of those? How about 2? So negative 2. Negative 4 divided by negative 2 is positive 2. The x comes down. Negative 7 divided by negative 14 divided by negative 2 is positive 7. How do I know I'm right? These match, so I write that one time. 2x plus 7. And then the two GCFs form the other factor. So the 5x and the negative 2. Okay? All right. Now, as you notice, like, look as I go through these different terms, like, these are all the same process. I mean, I did the same thing 6 times in a row, basically, just different numbers. So make sure you go through, you do the practice here, 9, 10, 11, 12, do some of that on the delta math so you get those repetitions, and you'll get better at it quickly. We'll continue to practice this all next week. Hope this helps.